Hello friends, in our previous lecture we have learned the methods which are iterative for solving the simultaneous algebraic equations. Now today we are going to learn another iterative method which is called relaxation method, which will give the more rapid convergence of the results than Gauss-Seidel method, and that can be used to advantage for hand calculation. It is the method which was not very well adapted for the computer application, but because it was originated for solving the engineering problems by the British engineer Richard Southwell, and mainly the problems applied to structural engineering area, this method was developed. So it is very important that we can understand this relaxation method. The method of relaxation is a scheme that permits one to select the best equation to be used for the maximum rate of convergence. We will illustrate this method by considering simple example. The original equations are 9x minus 2y plus z is equal to 50, x plus 5y minus 3z is equal to 80, minus 2x plus 2y plus 7z is equal to 90. Now we have to slightly rearrange the equations like shown in equation 1, where you rearrange the equation in such a way that these Rx, Ry and Rz are called as residuals in this method, and all the coefficients are brought on the left hand side. So if we begin, like in any iterative method, we begin with some value of starting value, some initial value to substitute to start our solution. If we begin with some initial set of values and substitute into equation 1, what we get? We get some value of the coefficient. That means we are not getting our equations which are satisfied on the right hand side, that is 0. That means some value which is called as residue. So in this example, if you substitute x is equal to 0, y is equal to 0 and z is equal to 0, you get Rx equal to 50, Ry is equal to 18, Rz is equal to 19. Now observe these three values. Which one is the largest one? You can see here the largest value is 50 here. You can see here Rx is equal to 50. So this tells us that first equation will be having most error because it is giving the larger value of the unsatisfactory value, that is the residual. We are getting more values as 15 as compared to other two, 18 and 19, this value. So we will have to improve, we pick up this equation, first equation, to improve. So the equation which is most in error should be improved first. The method gets its name relaxation from the fact that we have to make the change in some value of x. We have to take some value of initial value of x. Yx we have chosen because the first equation we are talking about, to relax the value of Rx, that is the greatest value. or of the residuals, so as to make it 0. We want to make residual 0, so we will pick up some value, initial value of x, which will relax Rx, that is to make it 0. So x value, if we can take it exactly equal to Rx, you know, why exactly equal to, see, if we increase the value of x by 1, you will be able to decrease the value of Rx by 1. And so that if we take the value of x is equal to Rx, we will be able to reduce Rx to 0. That is the main purpose of the method that we are going to see here. So also it is convenient when you write your original equation, this in the form of, like, minus 1 coefficients appear in your diagonal. That is number 1 here, or the point number 1 here, which is shown that it is convenient to rearrange equations so that minus 1 coefficients are on the diagonal, and divide each equation by the negative of its largest coefficient in the same equation. So for example, if I want to convert this equation 1 where I have the minus 1 coefficients in the diagonal, that means in first equation minus 9x, I have to make minus x there. Second equation minus 5y, I have to make minus y there. Third equation minus 7z, I have to make that minus z. Just to make arrange equation, because it is more convenient way to apply this method, relaxation method. So minus 9x we can, and additionally what the method says, that first equation all the coefficient to make the, we have to divide the equation with the largest coefficient of that equation, corresponding equation. So if you divide 50 minus 9x plus 2y minus z divide by largest coefficient is 9, so you can divide the whole equation by 9. Similarly, second equation, the largest coefficient is minus 5, and third equation largest coefficient is minus 7. So you can check here, I have written here Rx, Ry, Rz. Again here you can see the value of Rx, Ry and Rz. It is, you can check here, the minus x coefficient, minus y coefficient, minus z coefficient are having minus 1 value, and the whole equation is being divided with its largest coefficient, that is by 9. Second equation is obtained by dividing largest coefficient by 5, and third equation divided by the largest coefficient 7. Now this will increase the residual in the other two equation. If we decrease the equation 1 residual, because we have picked up the largest coefficient, largest residual, and we have picked up that value to take for our next initial value, and rest of the values are 0. If we do this, it is likely to happen that value of Ry and Rz will increase. So let's see what happens. So what we have to do now, next we are going to pick up the values of maximum value from R2 and R3. So next step will be, first we will take x equal to Rx, and that means increase x by the same amount as your residual. Next you have to pick up the maximum value from R2 and R3, because R1 is 0, to relax the greater magnitude of the residual as 0. So we continue this procedure of taking maximum residuals from each process. We continue this process until all residuals are 0, and when this is true, the values of final value of the solution is obtained by sigma x, sigma y, sigma z. Now these are the sigma rx actually, whatever initially value we have taken up for x, whatever initial values we have taken for y, whatever initial value we have taken for z, we are going to add it up, and that will be your solution. So let us see this example. Up to here it is being done. We have obtained this third equation, where you get this equation we have obtained. So out of this residual, you are getting, when you are substituting x equal to 0, y is equal to 0, and z is equal to 0, you are getting Rx as 5.56, Ry is equal to 3.6, Rz is equal to 2.7. Now pick up which is the maximum value, 5.56. So let's take, that is the first value that we are picking up. Here you can see x equal to 5.56, y is equal to 0, z is equal to 0. Now we evaluate the equation by substituting this x, y, z value. Same equation 1. Then you are getting new residual. Obviously Rx you are getting 0. Second, you are getting Ry is equal to 2.488, and third you are getting for 4.295. So out of these three, which value is maximum? 4.295. So for the next set, we select 4.295. Okay. So for the next set of equation, z is equal to 4.295, because it's the third residual, third equation. So we are picking up z, value of z is equal to Rx is Rz is equal to 4.295, and rest y and x0. Again, rewrite all the equation with the last residuals. This is very important. Obtain in the last step and calculate further by taking these values. So for your information, I have rewritten those equations again with the new residual. So instead of here 5.56, now we have replaced that residual with 0. Instead of 3.6, we have replaced that residual with 2.488. Instead of 2.71, we have replaced this residual with 4.295. So we are getting Rx, Ry and Rz with new calculated values by substituting z is equal to 4.295, y is equal to x equal to 0. Again we get new residuals. So we are getting Rx is equal to minus 0.476, Ry is equal to 5.065, Rz is equal to 0. So out of this is the highest, Ry is equal to 5.065. So we again further go further for taking now picking up Ry is equal to 5.065 as your y initial value. So y is equal to 5.065 and x and z 0. Again rewrite all the equations with the new residuals. Please understand, with the new residuals, and then you substitute this value into that equation. You can check that again one more time, that this was the equation we have used. This was the equation we have used. So here you have to change your residuals, and rest of the equation remain the same. Change your residual and evaluate with new values of your startup values, that is x, y and z. So it will give you this now. Again new residuals, pick up maximum value, that is this, irrespective of the sign. Please understand, we just have to see the magnitude, not the sign. So here 0.6 and minus 1.4, the largest value of the residual will be minus 1.4. So take z value as minus 1.4, x and y 0, evaluate again, and then you get this. So you continue this process, all this process I have written for your information, till you get very negligible, that is 0, almost close to 0 coefficients of the residuals. You can see here Rx is equal to 0.07, Ry is equal to 0, Rz is equal to 0.03705. So, sorry, 8705. So, final answer, as I told you, collect all values of the x residual you have picked up. For example, in the first case we have picked up x value of Rx as 5.56. Then in one of the cases, another cases where we have picked up a value of x as your 0.616. You can see here 0.616. You can see here 0.616. So adding only two times we have taken x equal to Rx. So we are adding up to get the final answer. Similarly, wherever we have picked up y value as your Ry for maximum residual. So Ry we have used here 5.065. Then Ry we have used here, sorry, not here, Ry we have used here, that is 0.13, and we have used Ry somewhere here, that is minus 0.865 here. So you get, add it, you get 4.33, which is your final answer. And last one, sigma Rz, you are getting whatever z values we have taken as your maximum residual value. For example, here you are getting here Rz 0.422, then here you are getting minus 1.423, and in earlier case second case, first case, here, yes, here you are getting, this was the value, Rz is equal to 4.295. So you are adding all these three values to get final answer. So this is your final answer, and it is a usual practice to write the relaxation method in a operation table like this. In this slide it is shown that this table shows that these are the coefficients after rearranging the equations. This is the value, initial values whenever we pick up as residual or zero values. So x, y, z is written here, and whatever residuals we are getting out by calculating, by substituting x, y and z in that value, Rx, Ry and Rz, you can write in these columns, these three columns, and you continue the process. You can write it in a tabular form for the convenient way of calculating. Simply x, y, z 0, and then second time we have pick up 5.56, calculated rest of the value with 0. We are calculating the next set of residuals. You can write in either same row or different row. That is, you can choose which way you want to make the table. And these are the problems and exercise that I have asked you to calculate using relaxation method.